we want to find the relations between the quantities in our diagram. And we know this is a force problem, so we're going to start with Newton's laws for each object, for each axis. There's only one object, so let's start going axis by axis. So along the x-axis, I have the force of friction is positive, and then I have that gravity, this component of gravity is actually going to be going to the left and down, which is negative. So let me go ahead and put a negative there. And what's the component going to be? So this angle is theta. The component of interest is opposite to the angle theta. So I'm going to be using sine. So this is going to be minus mg sine of theta, and that's going to be equal to ma. Now notice the box is going to be going in this direction, which is negative, so it's going to accelerate in this direction. So the acceleration is going to be negative. Let me go ahead and use that so that this number over here is positive. Okay? Okay, let's keep going. That's the x-axis. Now for the y-axis, what do we have? I have the normal forces going up, and then I have gravity, which is going down, and this time I want this component, which is adjacent to the angle theta, and so that's going to be minus mg cosine theta. And since the box doesn't move at all along the y-axis, this is going to be 0, which immediately tells me that the normal force is equal to mg cosine theta. What else do I know? Well, I know that the force little f is the force of friction, and the force of friction is given by this because it's kinetic friction. And I also know what the normal force is, so let me go ahead and plug that in. And so I can replace all of this stuff back into the first equation, the equation for the x-axis. Let's go ahead and do that. I'm going to get mu k times mg cos theta minus mg sine theta is equal to minus ma. So the m's are all going to cancel out. And let me move the minus sign over to the other side and factor out the g. So what I'm going to get is I'm going to get that the acceleration a is equal to g factor of sine of theta minus mu k cosine of theta. And so that is what I have found from using Newton's laws. I have been able to determine the acceleration of the box, which is exactly what I need for the next part of the problem.